Good afternoon everyone. Assalamualaikum. So we are going to continue with chapter 9, which is the first lecture out of 5, which is we'll be focusing on the first subtopic 9.1 Introduction to Random Variables and 9.2 Discrete Random Variables. At the end of this lesson, students should be able to, for 9.1a, to define and discrete and continuous random variables. And for 9.2, for part A, students should be able to construct the probability distribution table and probability distribution function. And for B, to find the cumulative distribution function. Variables was defined as the characteristics or attributes that can assume different values. Various letters of alphabet such that X, Y, or Z are used to represent variables. For example, if a dice is rolled, a letter such as X can be used to represent the outcomes. What are the outcomes? So because we have 6 surfaces for the die and each represent the value of the pin, then X can be 1, 2, 3, 4 or 5 or 6, corresponding to the outcome of the rolling a single die. Example 2, if 2 coins are tossed, a letter Y can be used to represent the number of heads, in this case 0, 1 or 2. Why? Because we are tossing 2 coins, so the outcome will be either head, 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 tail, tail, head or tail, tail. So we will have either no head or 1 head or both are heads, so 2 heads. Since the variables are associated with probability, they are called random variables. Definition of random variables. A random variable is a function that assigns a numerical value to each simple event in a sample. Usually, random variables are denoted by capital letters such as X and Y, and their corresponding small letter X and Y are used to represent a particular value of the random variable. So X is the random variable and small letter x will be the values. For example, if 2 coins are tossed and a letter X is used to represent the number of heads, then the number of heads, which is the X, the random variable, will be used to represent the number of heads. So what are the possible outcomes? Tossing 2 coins, we will have tails. So we don't have head here. That's why X is equal to 0. For head and tail, so the number of heads here is 1. And for tail, head, the number of head here is also 1. But for head and head, we have 2 heads for the number outcomes. Okay, so what is the value of X here? So we have 0, 1, 1, 2. So 3 values of X, which is 0, 1 and 2. Random variables. So we have 2 types of random variable. The first one is the discrete random variables, which the values that can be counted. For example, the number of cars sold at a dealership during a given month. The next example is the number of employees working at the company. Okay, all of these we can count. The number of complaints received at the office of an airline on a given day, the number of customers visiting a bank during any given hour, the number of heads obtained in 3 tosses of a coin. Okay, so we don't have the number in a points. It will be number that we can count it. So it will be a whole number. Okay. The next one is the continuous random variables. So these continuous random variable, there are values that are not countable or 1 or more intervals. So these are the following example. For example, salaries of workers in a factory, time taken by workers to learn a job, amount of water consumed by a family in each month of a year, the height of students in a college. So what we can do is to put this data in intervals. Example 2. Construct the probability distribution function if 2 fair coins are tossed and sketch the graph of the probability distribution function. So if we toss 2 fair coins, what we will have? So we will have either head, head, head tail, tail head, or tail tail. Let x represent the number of tail obtained. Then our x will be, maybe it's 0 tails, or 1 tails only, or 2 tails. So from the outcomes, we can represent this probability distribution by sketching the table. So what we need to put in the table is the value of x. What is x? The number of tail obtained. So we will have 0 tail, or 1 tail, or 2 tail. So what is the probability for each of the x? So we see the outcomes because for the 0 tails, we have 1 outcomes. So it should be 1 out of 4 because we have 4 possible outcomes. So 1 over 4 is the probability for x equal to 0. And then how about 1? Because we have 2 outcomes when tail equal to 1, then it will be 2 out of 4, which is equal to 1 over 2. And for when the tail is equal to 2, the tail is only 1 outcome out of 4 outcomes. So the probability is equal to 1 over 4. So this is the method 1, which is by drawing the table. The second method is to sketch the graph and write down the function. So how to write down the function? First, we can let the function as probability of x equal to x, or small letter of f of x. So this will be the function of the probability distribution function. And then because we have 2 possible value of probability, 1 over 4, 1 over 4, and 1 over 2. So the function can be written in a form of piecewise function. So this probability function can be written in a piecewise function of 1 over 2 for x equal to 1, and 1 over 4 for x equal to 0 and 2. And the next method is to sketch the graph. So what we will have, we write down the x value on the x-axis, which is we have 0, 1, and 2 for the value of x, and the y-axis as the probability of the x equal to x. So when x equal to 0, the probability is equal to 1 over 4. So for 1, the probability is equal to 1 over 2. And for 2 also 1 over 4. So what we can do, we can sketch the graph like a straight line from the x-axis. So for 0, it's going up to 1 over 4. For 1, it's going up to 1 over 2. And for x equal to 2, it's going up to 1 over 4. Okay, so this is the graph for the discrete probability distribution function for discrete. Okay. Probability distribution of a discrete random variable, the list of all possible values of random variable x with their corresponding probabilities is known as discrete probability distribution. Okay, the total probability for this distribution x is known as so the total of probability of x should be equal to 1. The probability for each of the value of x should be in between 0 and 1 inclusively. Why? Yeah, this is a probability. Probability cannot be negative value, and probability cannot be more than 1. And the total probability should be 1 for the event. The probability distribution can be presented in the form of table, function, and graph. The mode for discrete probability distribution is the value of x that is most likely to occur. Consequently, the mode is equal to the value of x at which the probability distribution function probability of x equal to x reach a maximum. So if we relate the mode in the data description, it is said that it has the highest frequency or repeated many times. So for this one, what is the highest probability for the x? So that will be the x will be the mode. For example, the probability distribution function of a discrete random variable x is given by probability x equal to k multiplied with 4 minus x, and for x equal to 0, 1, 2, and 3. Given that k is a constant, find the value of k. So what do we know about probability distribution function? We know the fact that the probability must be in between 0 and 1 inclusively, and the total probability should be equal to 1. So we have the value of x 0, 1, 2 and 3. So we can find what is the probability for each of these x in terms of k. So for x equal to 1, 0, the probability will be equal to, so we just substitute value x into the function. So k multiplied with 4 minus 0, so 4k. When x equal to 1, it will be 3k. When x equal to 2, probability is equal to 2k. And when x equal to 3, the probability is equal to k. So, and as we know, probability distribution function, the total probability should be equal to 1. So, total up all the probability we have in the table. 4k plus 3k plus 2k plus k is equal to 1. So, k is equal to 1 over 10. So, now we found the value of k by using the properties of probability distribution function. Cumulative distribution function. Okay, this cumulative distribution function is different from the probability distribution function because it's obtained from a frequency table by summing all the frequencies of probability up to particular value. So it's like cumulative the frequency in the data description. So the resulting function is known as cumulative distribution function. Let's say for discrete random variable, if x is a discrete random variable with probability distribution function p of x equal to x for x equal to x1, x2 up to xn, then the cumulative distribution function of x is denoted by capital F of x given by probability of x less than or equal to x. Let's say we want to find capital of 2 and we have x equal to 0, 1, 2, 3. So this probability is equal to x less than or equal to 2. So what is included for x less than or equal to 2? It should be probability of x equal to 0, total up with probability of x equal to 1, up to probability of x equal to 2. So we are totaling the probability from x to the value before the x. The median m is the value when probability of x less than or equal to m equal to 0.5 or capital of m equal to 0.5. So if we have the function, the cumulative distribution function, capital F, you just substitute the x as m equate to 0.5 to find the value of m. Example 4. The probability distribution of a discrete random variable x is given in the table below. So we have x equal to 0, 1, 2, 3. The probability of each of it for x equal to 0 is equal to 1 over 8. For x equal to 1 is equal to 3 over 8. For x equal to 2 is 3 over 8. And for x equal to 3 is 1 over 8. Now the question is asking you to find the cumulative distribution function. So capital Fx. And then sketch the graph. And the next one is to find the median. So how to find the cumulative distribution function? So we have 0, 1, 2, 3, the value of x. So we can just directly from the table, it's easier to use the table to find the probability of x less than or equal to x. So the same as the cumulative frequency for data description, we just add up with the previous cumulative function, cumulative values. So for this one, 0, it should be adding up the 0 with the previous one, which is none. So just directly take the frequency, which is 1 over 8. But for x equal to 1, so for probability of x less than 1, so we have to take the value for x equal to 0. So just add up 3 over 8 with the cumulative before that, which is 3 over 8 plus with 1 over 8, we get 4 over 8, which is equal to 1 over 2. And then for the next one, just add up the frequency with the cumulative before that. So 1 over 2 plus 3 over 8 will be 7 over 8. And the last one, probability of x less than or equal to 3, we must include 2, 1 and 0. So we just add up with the cumulative probability before that class. So we will get 1 over 8 plus 7 over 8, which is equal to 1. So this is the easiest way to find the cumulative distribution function. But this is in the table form. If they want you to put the function, we need to write down in function form, which is the piecewise function. Okay. So find out for each of the x. So we will have the interval where it must start from x less than the first value, which is x less than 0. Okay, so for x less than 0, capital Fx is equal to 0. So that is the starting point. And then the next value, you must include 0. So probability of the x should be in between 0 to 1, where 0 must be included. So we have equal sign at the 0. Okay, so this is for when x less than or equal to 0. So the capital Fx is equal to the probability of x equal to 0 only. Directly we take 1/8. And then for the value of 1, so we have to put the interval of x in between 1 to 2, where 1 must be included. So the capital Fx is equal to, we need to include 0 and 1. So that's why probability of x equal to 0 plus probability of x equal to 1. Okay, the same what I do earlier. So we have 4/8, which is equal to 1/2. And then for 2, so x should be in between 2 and 3, where 2 must be included. So the capital Fx for the 2 is including the 0 when x equal to 0, when x equal to 1, and when x equal to 2. So that's why we add up the cumulative before that. So this is the same as f of 1. What is f of 1? This one, 1/2 is f of 1. These two, the total up between x equal to 0 and probability of x equal to 1 is like f1. So 1/2 plus with 3/8, we get 7/8. And the last one, so how to put the interval? It should be x more than or equal to 3, because this is the last value. And the probability, the cumulative probability function, capital Fx should be equal to totaling up everything. So it will be equal to 1, because we are totaling up all the probability for each value of x. So write down this in the form of this piecewise function. So capital Fx is equal to 0 for x less than 0, 1/8 for x in between 0 to 1, where 0 is included, and 4/8 or 1/2 for x in between 1 to 2, where 1 it must be included, and 7/8 for x in between 2 and 3, and 2 must be included. And the last one is 1 for x more than or equal to 3. And then the next question is to sketch the graph. Okay, how to sketch the graph? So we will have how many intervals? So we have the value of 0, 1, 2, and 3. So on our graph, we should have this value of x, 0, 1, 2, 3. Okay, you want to put more than that, then it's okay too. And then the probability we have is 0, 1/8, 1/2, which is 4/8, and 7/8 up to 1. So just following the interval of x given in the function, for x less than 0, the probability will be equal to 0. Okay, so this graph must not include 0, so that's why we have the empty dot here. To the back of 0 will be 0. And then for x in between 0 to 1, where 0 must be included, we have the dense dot here and empty dot at 1. The probability, the value of y is equal to 1/8. And then from 1 to 2, where the 1 must be included, so dense dot at 1 and empty dot at 2, the probability or the value of y is equal to 4/8. And from 2 to 3, dense dot on 2 and empty dot at 3, the probability should be 7/8. So the value of y, it should be 7/8. And the last one, from 3 above. So from 3, dense dot up to the right side of the value of x, so the probability should be equal to 1. So difference between the PDF, probability distribution function, and the CDF, cumulative distribution function, that the one earlier, the shape of the graph is look like a what we call it, matches, right? Macam mancis. For this one, it looks like a stairs. Okay, so that is for the cumulative distribution function. And then the next question is to find the median. What it means by median? So we've known earlier that the median is when the probability of x less than or equal to x equal to 0.5, or capital of f of m is equal to 0.5. Okay, so where is the area where the cumulative distribution function equal to 0.5. So this is the area. This is when the dense dot equal to 1. So F1 is equal to 0.5 means that the median is equal to 1. Okay. The next question, example 5. The cumulative distribution of a discrete random variable x is given in the table below. So we have x equal to 1, 2, 3, 4 and 5. And the cumulative distribution, okay, this is a cumulative CDF. So we have 0.05, 0.3, 0.6, 0.75 and 1. So the last probability should be equal to 1 because this is probability of x less than or equal to x. So the question is to find the probability distribution table of x. So they want you to give the table, means that we can just use the table given in the questions. So directly from the table, so we just copy back the table. Okay, so we have the value of x and we have to put the probability of x equal to x. So what is our x? We have 5x which is equal to 1, 2, 3, 4, 5. And the probability for each of these x, so for the first one, we just copy back everything, 0.05. For the second one, it's 0.3. But 0.3 is the cumulative. What we need to do is to subtract with the previous probability. So 0.3 minus 0.05, so it will be 0.25. And for the probability of x equal to 3, just subtract probability of x less than or equal to 2 here. So 0.6 minus 0.3 is 0.3. And do the same for 4, we get 0.15 and 1 minus 0.75 is 0.25. So we can check to make sure that this is correct is by totaling up this probability. So 0.05 plus 0.25 is equal to 0.3. 0.3 plus 0.3 is 0.6. 0.6 plus 0.15 is 0.75. 0.75 plus 0.25 is equal to 1. So the total is equal to 1. So correct. So this is how we do the probability distribution table. So if the question asks you to write down in function, then you have to do the function. Or graph, you should sketch the graph. Okay, the next question is to find the mode. Okay, so let's check. So this is just the working. So you just subtract with the previous class. Okay, and then how to find the mode? The mode is 3. Why? Because from the probability distribution table, the highest frequency is when x equal to 3, where the probability is equal to 0.3. Compared to other values x, the probability here is the highest. So the mode is the value of x here, which is equal to 3. Okay, notice that the total probability should be equal to 1. So that's all for the discrete random variable. So you can try to do the tutorial for the lecture 1. Okay, thank you.